Okay, this is sort of a do-over for me. I tried this a little earlier and it didn't record sound, so hopefully this will work for us. This week's lab, what we're looking at are bones of the axial skeleton. And with the axial skeleton, what we're talking about are bones in the midline, basically the axle, as it were. So we're talking about the skull, the sternum, rib cage, spinal column, sacrum, and coccyx. We're talking about all the bones not associated with movement, essentially. And if you go to the laboratory area of online labs, what you'll see is first there is a virtual site or a link to the virtual site, and this has the axial skeleton, which includes the skull, the vertebrae, miscellaneous bones. Also, it has a list of bones that I want you to know for the lab, and if you scroll down here, you'll see that those are listed here. Now, we have individual bones listed in bold, and structures that are on the bones are indented and listed in, not bolded. Now, you'll also notice that there are some numbers there. If you go back to the virtual lab, if we pull up this, there are numbers that are located on the images on the virtual lab, and those numbers correspond to these numbers. Now, I'm going to go to a separate little screen here so I can do some three-dimensional work and kind of show you these different structures. So we're looking at bones of the axial skeleton. Let's take an overview here. And the first bone that we're looking at is the frontal bone, which is right here. And we only have a single bone like that. Most of our bones actually are paired, with the exception of a few, like the maxilla, mandible, and the frontal bone. So we have like 206 bones in the human body, of which we're going to learn about 30, as because we're going to name some groups of bones just as a group. Like there's 8 carpals in each wrist, but we're just going to know that group as carpals. There's 5 metacarpals in each hand, and so forth. So in the end, we end up knowing about 30. Now, these first bones that I'm talking about are cranial bones. Cranial bones, by definition, actually come in contact with the brain. So we have our frontal bone. And then this green one here, those are the parietal bones. And you can see we have a suture that runs down the middle that separates those two. And they make up the top part of the head. So those we just need to know the bones. Now here we have the occipital bone. And when you think occipital, you can think ocular. It is back here, back of the skull, and this is where our visual processing area is. Now if you take a look at this list, there are a couple of structures that you need to learn that are on the occipital bone. And those include the occipital condyles, which are these areas located here and here, and the foramen magnum. Now, foramen is a opening, magnum is a big something, so the foramen magnum is the big opening in the base of the skull. And you can take a look here. And again, you can see that number, foramen magnum, and the occipital condyles located here. So those are our major structures on the occipital bone. Now we get to go to the temporal bone, and you can learn a little bit about a bone just by its name. So temporal bone, named after its location, it's right in here, and it's this big red bone. There are a couple of structures here. This is the zygomatic process of the temporal bone. It meets up with the temporal process of the zygomatic bone to make this structure called the zygomatic arch. And this structure basically allows us to chew. See, right along here, we have a large muscle that goes underneath that bone and attaches to this process on the mandible and allows us to clinch. So you can actually fit your jaw together and feel that muscle expand. Additionally, another muscle called the masseter right here attaches to the mandible and attaches to the underside of that bone. Other structures on the temporal bone include the external auditory meatus. And a meatus is sort of a dead end opening. It's like a cul-de-sac in a neighborhood. So this goes into our head, or the tympanic membrane, and that is where our sense of sound is located. We have the mastoid process, which is this big knobby structure underneath. And for bones, we get large processes sticking out, usually when there's something pulling there. So on that case, we have this large muscle, the sternocleidomastoid, which is attached to the mastoid process, the sternum, and the clavicles. And that muscle pull allows us to turn our heads left to right and other movements like that. We also have, on the underside, this little fin sticking out. And that is the styloid process. And there is a ligament that goes from the styloid process from here down to here, which is the stylohyoid ligament. And it's associated with, it holds that hyoid bone in place. And the hyoid bone is the bone that allows, or that our tongue is attached to. So the hyoid bone is the only freely floating bone in the body. It's the only one that is not directly in contact with another bone. And it's because of that ligament that we are able to do some things like talk and swallow and things like that. Other structures on that bone, let's see, mastoid process, mandibular fossa, yes. And you're going to see that on these skulls right here. It is this little dipped out area right in here that is part of your temporomandibular joint. And that structure, which is located right here, allows us to open and close our jaws. And this is a fairly complicated joint because these are condyles, and a condyle allows movement in a couple of different planes. So when you chew, you swing your jaw to one side, and in doing that, this part on this side stays in that little pocket. But on the opposite side, it actually slides down and forward and comes out. So those are the major processes there. We talked about, just for clarification's case, in case I didn't mention it, this is the zygomatic arch. Now, let's go to our next bone, which is the zygomatic bone, which is this orange bone here. The zygomatic bone actually makes up part of the floor of the orbit, so it helps keep the eye in place. It makes up part of that zygomatic arch, and it attaches in here. Now, don't call this the cheekbone. If I ask what it is, it's the zygomatic bone. And one thing that can happen here, because you'll notice these connectors are relatively thin, these sutures are, and a good solid blow here can actually break the zygomatic bone and make it loose so you can dislodge an eye with that. We have a protective mechanism against that. We actually have a fat pad located right here to prevent a blow from doing much damage. Now, if you remember Kate Moss, she wanted to really accentuate her cheekbones. Just wanted to look more like a skeleton. She was a super thin model, and she had them surgically go in and remove that fat pad from underneath here. You can go in intraorally and take that out. So it made her look thinner, but it also made her more susceptible to injury in that case. Now, the nasal bones are these two guys right here. There. And those bones kind of make up the bridge of the nose. If you've ever heard people say that you could kill someone by hitting them really hard in the nose, this is what they're talking about, because this, again, not got a heavy attachment, and the bone is really, really thin right here, so you can hit someone here and actually shove those up into the brain and lacerate the brain, basically performing a lobotomy on them, or prefrontal lobotomy. So, yeah, I used to like to call this class 100 Ways to Kill a Guy, and I will show you at various times certain weaknesses that the human body has. Now, if we go to the next bone, this is the maxilla. It's this green bone here. And this bone, its chief job is to hold teeth in place. It also has some hollow areas here, which are the maxillary sinuses, which allow our voice to reverberate a little bit. But the main purpose is to hold teeth. And the downside is that the body doesn't maintain a structure that it doesn't use. So if you have the teeth removed, and you can see that the roots of the teeth go way up in there, eventually this part of the structure will dissolve away. And that will end up leaving this relatively flat, and it's actually this horseshoe shape that helps keep a denture in place. So if a person had their teeth taken out when they were young, by the time they're in their 60s or 70s, they may not be able to get a denture that actually fits very well. Now, let's go to our next set of bones, and we are looking at the lacrimal bone. So let's back up here. And the lacrimal bone, it's this little purple bone right here. And it has a structure in it. It's got a hole. And I can show you probably better here. Let me see. Well, we don't have a great picture of it here. But right there, this is the lacrimal bone, and there's a hole right there that allows tears to drain down from the eye into the nasal cavity. Now, you may have had the experience where you started crying and suddenly your nose is stopped up, and that's not snot, that's tears going down that opening and draining into your nasal cavity here. I had this set as just 2 videos, but one of them was a little bit longer than the 15 minutes that's allowed by YouTube. So I'm breaking it up into 2 separate ones, around 10 minutes apiece. And the third one will be about 15 minutes that will cover the axial skeleton. So this will be part 1A, and the next one will be part 1B.